Hello everyone and welcome. Our team, consisting of Luis Palomino, Braulio Vargas, and me, David Robles, is proud to show you today the demo of our implementation of one of the biggest arcade games of all time. We of course are talking about Pacman. But before we start, I would like to go through the steps of showing how this project came to be. We will start with the main two subjects of the game, which are Mr. Pacman and the Ghost. Each have a different objective and behavior. To show them, we made two state diagrams, starting with Pacman, in which we can observe the following. He has only four states, starting with walking, which is basically moving around the map, eating power up or a power pallet comes to powerful, then he can either win or lose the game, which is win, eats all the pallets on the map, or lose, dead, which is caused by being touched by a ghost. Then moving on to the ghost diagram, we have a little bit more states, and we start with the idle state, which is the spawn at the center. Then they begin to move out and move around the map, and then they begin a chase with Mr. Pacman. Then from each state they can go, for example, into a fleeing state, which is when Pacman eats a power up. They begin to flicker at the end of it, and they can also get eaten, which is the ghost respawn at the center. Also, I would like to mention that this project uses the Ebi10 game library, which is a Go library freely available to make video games, has touch controls, keyboard controls, audio and video, and other utilities. Now, without any further ado, Palomino is going to begin showing you the sequence diagram of the game.
Okay, so we're going to see a simple use case of how the game plays out in a sequence diagram. So we have the game controller, which is responsible for transitioning between screens. In this case, we're initializing the level screen because we want to play. The level screen will initialize Pacman, ghosts, the maze structure, or any other objects that are used in the game. Then the game controller runs the level screen Go routine, and the level screen initializes the Pacman and the ghost Go routines. Now, the Pacman Go routines, or while the game is running, it will check for user input, then it will move the object, move itself if necessary in the maze structure by acquiring a lock first. Of course, change state if necessary, and then sleep until it's time to wake up again next frame. Ghost does something similar. It picks a direction instead of listening for user input though. This direction, or how it picks the direction, will depend on its state. Then of course it can move the object in the maze structure, it can change state, or it can sleep. And the level screen's Go routine, well, it's listening for events that can come from Pacman or the ghosts. Now the drawing logic is all handled by a different Go routine, mainly called by the Ebi10 library. So it's basically like a different thread or Go routine that calls the level screen draw method, and then the level will call the maze draw method in order to draw this current state of what's happening in the game. And of course, at the end of the game, the level will send a message back to the game controller indicating that the game is over and the game controller is responsible for switching to a different screen. So we're going to take a quick look at the code and some of the most important parts. So this is the run method of the level struct, which represents the screen of the game. This run method, after initializing everything that it needs to, it will initialize or run the Go routines for the player and every Go routine for every enemy in the game. Then in the main loop, what it's going to do is going to be listening for events that can come from either Pacman or any ghost. Some events are when the Pacman eats a power pellet or when the power pellet wears off. So now we're going to move on to the ghost. This ghost is a struct also. And something important about here is that it has a state, which is an interface, a ghost state, and a chase behavior. These interfaces have more like specialized structs or actual implemented structs that define a different behavior for the ghost. So of course, the state, we saw the ghost state diagram. It's going to represent the behavior, or it's going to take care of the behavior of the ghost in that specific state. And the chase behavior is going to be, it's going to handle the different behaviors of the ghosts. So some ghosts can chase the Pacman in a different behavior. And of course, we can go to the um, most important method, which is the run method. This run method will handle, well, while it's alive, it's going to be doing three things. It's going to lock the maze mutex so that the ghost can only access it and know what's the state at that specific moment. And then it's going to call the run method of its current state. So the current state is going to handle what's going to happen there. Pacman, something similar. Pacman also has state. So what's going to happen in its run method is while Pacman is running, so it's not dead or hasn't won, it's going to, of course, lock himself, and it's going to call the run method in of his current state.
To run the demo, we have to go to the repository and download the zip. After that, we are going to extract the files, and we have two options to run the program. The first one is where we compile only the program, and after that we specify the number of enemies. And the second one, we can do it from the make file. With make run enemies equal the number of enemies. Here in the computer, we had downloaded the zip before, so now we're going to show you where we have located on downloads. So now we have on terminal, we can run the make run enemies equal the number, and the program will start. Player starts on the center of the map, and he has to wait 5 seconds to start moving. After that, he can go through the map wherever he wants. Now, we have two kind of points on the map, the big ones and little ones. The first one are the ones that allow us to take the enemy and reset them on the center of the map. And the second ones are the ones that affect our score. The main purpose of the game is to get all the little points so we can win the game and go to the screen of game over, where we are going to have the maximum number of score. However, if we get caught by a ghost, we're going to end it, and that is a directly game over with the current score. In this point, we're trying to reach the winning, so we're going to play carefully and try to win, get all the points, and show you how the screen of game over is displayed. Now we're going to show you how it works when you end the game, when you get caught by the ghost. So now we're trying to get the ghost where he's running really fast. And now we have the screen of game over with the current score. The complexity of the game depends on the number of enemies that we have on the map. Now we're going to show you how it works when you have 5 enemies on the map, and also that is really hard to win when you have that amount. Now we have 5 enemies. That means 5 threads and 1 thread per enemy. So as we can see, each one of them can move randomly through the map and try to reach the player. So we can defeat them if we get the big points and try to kill them. However, they're going to respawn on the center of the map, and they can kill us when they are in the normal state.
So personally, I really enjoyed the project. I thought it was a good way to learn Go in a deeper level. For example, I used interfaces to implement kind of like polymorphism. Spent a lot of time reading about in forums about how to do some stuff in Golang that you would normally do in an object-oriented language. I also thought that working with coroutines was pretty cool. I feel a bit more comfortable now working with them after spending all this time in this project. So yeah, I think it was a very good project.
My career working with threads was a pretty difficult thing for me. It was like a messy stuff where you can have to share a variable, and if you do not do it in the correct way, you're going to mess with the program. But with this project and working with Golang allowed me to understand better how they can use it and make something productive that can be a parallel program that makes something great.
Hello, so my personal key learning and challenge was actually working with the EV10 game library, especially since it has two main versions, V1 and V2. That also with the fact that it's not a very widely used library, didn't have a lot of documentations, specifically on the problems we encounter, but overall, I think it's a very rewarding challenge having completed this project.